is a projectile motion trajectory. What is this? This is called trajectory. What is the meaning of the word trajectory? Okay. Projectiles trajectory. The meaning of the trajectory is any path which is followed, right, under the influence of gravity or any other force will be called as a trajectory. Right? First thing you should know about projectile is that a projectile has a trajectory. The shape of the path is this. And this path is parabolic. The shape is parabolic. So the trajectory of the projectile takes the form of a parabola. You would hear this term many places, trajectory, parabola. Let me just bring them together. Okay, I hope this is making sense. Okay. Now when we draw this graph of the trajectory, which is parabola, on the y-axis you have vertical distance. And on the x-axis you have the distance which is horizontal. So when you throw a projectile, it will go like this, like a parabola. It will go forward in x-axis. It will also be going up, and then second half of the motion, it will be going down. So it has two motions, one x-axis motion and the y-axis motion. I will discuss both, but as an introduction, what you see in front of you generally is this figure. So you should know it's called the trajectory. It's a parabola. On the y-axis is the vertical distance of the projectile. On the x-axis, you have the horizontal distance being covered by the projectile. The purpose is get familiar with this figure. Now I will come to the basics, okay? If you did not understand this, let's go the other way. Now what you do is you launch a projectile from here, right? So that's your launching, right? So you are launching the projectile with velocity u, making an angle theta with a line, okay, which is x-axis. This line, which you see as the x-axis line, okay, is called the ground line for reference. Ground line for reference. I hope you can see this, right? So all the measurements are going to happen with reference to this, okay, with respect to this. We'll come to this, but you should know that the measurement of angle theta is from the ground now, okay? This is your ground. I'm standing here, I'm on the ground, okay? If I throw something, the angle will be measured from this place, right? Because I'm not really throwing something from the ground, throwing at a height, right? So you should know what is the reference point from where the body starts moving. So the reference point is this. It's a ground always, okay? Not always, but this situation is ground. And the body is coming back to the ground. So this is called a ground to ground projectile. Ground to ground, okay? There are other types which we will discuss later. So you have thrown a body with a velocity of u at an angle theta, which will follow this trajectory. Why? We will discuss that. And will reach some points on the trajectory. The farthest point, the highest point, the launch point. So you can see three crucial points. Launch, highest, the farthest, okay? You may have heard these terminologies, okay? Now, when you launch it, there are parts of this, okay? So there are two parts to this. One is the initial velocity is divided into two parts. So the first part is u cos theta, right? So this is your initial component of the launch velocity, which is u at the point of launch, Then at the point of launch, it also has u sine theta is equal to uy. So first thing first, you have what is the initial velocity of the projectile? Two components. We will split this whole motion into two components to understand it. We will split the whole motion into two parts to understand the motion, the x part and the y part. We are starting with initial velocity. We have already done the division of initial velocity. Now, second, what happens to this at a time t? At time t, for example, the body reaches here, the velocity in the x-axis is u cos theta. The velocity in y-axis is so the motion has two parts. One part which is under the influence of gravity, which is a y part, as you can see from the velocity at time t, and a x part which is horizontal part. Together, what they do is the creation of this path. A projectile is a type of motion or a trajectory where the body is under the influence of gravity in y-axis, and in the x-axis, the body is in uniform velocity. A lot of people do start from this place, definition, but you must get the context right. Generally, what you do is you get this figure in front of you, and therefore it is important to first clarify what is this figure all about. But the traditional definition is, if you have a body which is launched in the y-axis, if you have gravity, and in the x-axis you have uniform motion, which means the x-axis velocity never undergoes any change irrespective of time, which means it never changes. The x-axis velocity never changes throughout the motion, never changes. But the y-axis motion undergoes change because of gravity. The combined motion, which is the motion under the influence of gravity, and the motion, which is uniform motion in the x-axis, the combined motion is called the projectile motion. Okay? That's a definition. If you don't have gravity, if you remove gravity, you will, from here, which is a launch, and remove, no, there is no gravitational field here, you will not get a projectile motion. Second, a projectile motion, when we split it into x and y axis, they are independent motions. They are not dependent on each other. The y axis motion happens as an independent motion. The x axis motion happens as an independent motion. You really can't mix these two. They are separate. The only commonality between these two is a time. If there are 5 seconds which have elapsed in time dimension, they have elapsed for x-axis and y-axis. So in 5 seconds, the body will go up or down in y, and in x-axis, it will go far in the same time. So that's a, so to say, a bit of linkage there. But otherwise, they are completely independent. You do get questions on independence, the very basic concept of projectile motion. So I will just summarize what we have done so far. We have understood that the motion is divided into x and y. The y has gravity, x is uniform motion. Together they form a projectile motion. The projectile motion trajectory is a parabola. In the y-axis of this graph, there is vertical axis motion, which is in meters, the vertical displacement. The x-axis represents the horizontal displacement of the projectile. right? I hope this is making sense. The combined impact of gravity in y-axis and the uniform motion in x-axis together results in a projectile. All right. So let's get slightly deeper into the concepts. Even if you know projectile, later half you will know some excellent points that will help you solve the problem. So stay with me. Even if you know these basics, in the end, I will tell you some very beautiful insights which will help you solve the problem. So you can move forward, if you know all of this, to the end of the session to enjoy those points that will really help you solve the problems. Okay? It's a deep analysis of projectile. All right. So far, we've understood there is initial velocity, there is a final velocity at a time t. So I can show it like this. Okay, so this is my final sum at time t, my velocity vy, and this is my horizontal velocity, which is ux cos theta, right? Which is never changing. The x-axis velocity is never changing. Now, let's talk about the displacement after time t. Since we've already talked about initial velocity, final velocity, obviously we need to talk about the position of the projectile or its displacement from x-axis origin and y-axis origin, origin itself, in time t. So x is equal to u cos theta into t. This is the distance traveled by the projectile in time t. This will be measured here. Okay. So right now, the projectile has reached this point. Okay. So let me just draw a perpendicular here. This is my position of the projectile after time t in x-axis. Distance, speed into time. What is the displacement of the projectile from origin in vertical axis? Y is equal to u sine theta t minus half gt square, governed by the second equation of motion, accelerated, uniform accelerated motion in y-axis, only gravity. You can see we can find the position of the projectile at a time t in both x and y. So this y is this. This is the displacement of the projectile in time t, right? So we are able to find everything about the projectile using equations of motion. In x-axis, we are just using the uniform motion concept. In y-axis, we are using the concepts of uniform acceleration. All right. Now, we know the initial velocity components. We know the final velocity components. Okay. And then, I think I'll just correct this. Okay. So this is Vy is equal to minus Gt. Okay. Just a small correction. It is minus Gt. And now, we also know the position of the projectile in x-axis and y-axis after time t. Let's go deep now. I said initially, just for the purpose of introduction, that this motion is a parabola. Why did I say that? Because I knew it, but there is a mathematical derivation. If you pick up these two equations, which is the x-axis and the y-axis, and you remove time, which means you put t is equal to x upon u cos theta, and you substitute this in the y-axis, solve it, you will get equation of the trajectory. That equation is this: y is equal to x tan theta minus gx square upon 2u square cos square theta. Memorize this and understand the derivation. We remove time. This equation has no time in it. This equation is a quadratic equation. We will discuss what does it signify. But for the time being, when you see this graph of y versus x, the equation of this graph is a parabola quadratic equation, which is this. First deep point, many questions can be solved with the help of this equation. Use it when you don't see any time. The time is missing in the problem. They're trying to link x and y. Use this. All right. Also, when I started, I mentioned about some crucial points on the projectile motion. One, the highest point. So you are able to reach the high, very high of the projectile. Highest point is called Hmax. Here, the vertical velocity, which is this, the vertical velocity becomes 0, and therefore 0 is equal to u y sine theta minus gt, and therefore gt is equal to u y sine theta and t is equal to u sine theta by g. This time is the time taken by the projectile to reach the highest point. And then the second important point is this, okay? The range. What is the farthest you can travel? When you reach the farthest point, you have no vertical displacement. When you reach the farthest point from the point of launch, you have no vertical displacement. In y-axis, your y is 0. Put y is equal to 0 here. We will solve this. Wait for that. Now we calculated a time. Remember, projectile motion is a symmetric motion. Now the deep analysis of the motion is commencing. Listen through very carefully now. The projectile motion on the left hand side and on the right hand side, if you draw this vertical line, the highest point, they are mirror images of each other. Whatever happens on the left hand side also happens on the right hand side, but it's a mirror image. The projectile motion is symmetric. About this point, this line, okay? The line coming from the highest. On the left hand side and on the right hand side, whatever happens on the left hand side also happens on the right hand side, but as a mirror image. Now, if you notice, we calculated this time t is equal to u sine theta by g, which means this is on the left hand side. This is a time taken by the projectile to cover half the projectile, half the motion. The other half will also be the same. So I will add another time and make it 2u sine theta by g. This time is called as the time of flight. The total time taken by the projectile to cover this trajectory is called the time of flight. The logic used was symmetry. We knew half the motion takes this much time. By symmetry, the second half also takes the same time. You can easily do that also. Find also. So now you know that the time of flight is equal to seconds, or whatever dimension or unit is given to you. Memorize this, very important. Now, if you use this time t, the total time of flight in the horizontal distance. So what is the horizontal distance traveled through this time of flight? Obviously, you will reach the farthest point, the range. The range is the maximum horizontal distance traveled by you from the point of launch in the time, which is this. So if you substitute this time in the horizontal displacement expression, speed into time, here put this time, you will get the range of the projectile. U square sine 2 theta by g. Memorize this. Very, very, very important expressions. Time of flight, range, and if you use half the time of flight, which is this, in the vertical displacement expression to find the highest point, right? Highest point is achieved when the t is half the time of flight. Substitute it here and you will get your y-axis displacement in half the time of flight, which is going to be your Hmax. U square sine square theta by 2g. Memorize. Very important. If you know all of this, more to come. And these are the real insights which are coming now. Because I use the word symmetry. And now I'm going to introduce those topics which will really help you understand this motion. Solve the problems easily, short tricks. But you need to have a basic knowledge of what exactly is happening during the motion. All right, so let's move. I said the motion is symmetric. What exactly does it mean? What does it mean to you? Obviously, the motion is symmetric. The left-hand side of the motion mimics the right-hand side of the motion, or vice versa. But how? Let's see an example. Let me pick this point, okay? This point after time t has a certain velocity, which is v, which I divide into vx and vy, okay? The height of this point, which is a vertical height, y-axis, which is this, is given by this line, okay? So let's say this is the vertical displacement, okay? Let's go to a point which is symmetric to this point. Let's go there, okay? So by what I do is I draw a line which is going to help me find the point of symmetry, okay? In the middle is Hmax, and here this is my point, maybe x, and my mirror image about the central axis, which is the Hmax, is x dash, okay? So this point, which is located symmetrically, is also at the same height as this point. If this height is 5 meters, this also is 5 meters. We're talking about symmetry now. My emphasis of this part of the video is symmetry. And now see what happens. So your velocity here is v, your angle here is, say, with the horizontal theta, right? Let's see what happens to velocity. Does the velocity mimic? Let's see how it mimics. So the direction of velocity is obviously going to be downward. You will notice that the magnitude of this velocity is same as this velocity, but in the downward direction. So this velocity is going to be v in magnitude. Same velocity which you see here is observed here because the points are symmetric. Symmetric points exhibit this. If the velocity here is v making an angle theta, here the velocity is going to be v making an angle of minus theta. That is the only difference. So here the components of the velocity are v cos theta and v sine of minus theta, which is v cos theta, comma, minus v sine theta. But here the components are going to be v cos theta, because in x-axis nothing changes, and in the y-axis v sine theta, right? Identical velocity, direction obviously, if one of the direction is this, the other direction is this. The angles are theta and minus theta with the horizontal. But these 2 points are characterized by symmetry. So the velocity mimics. It's a mirror image. A mirror image is, inverted in some sense. The left appears right. Something very similar. All right. Now let's talk about how are these two symmetric points linked to each other. They have same vertical velocity. Sorry, but in magnitude, they have same vertical displacement also. And the axis of symmetry is the central point, right? This is your axis of symmetry. So what's happening now? If you consider this equation, right? If you consider this equation as an example, you will notice it is a quadratic in x, which means for a given height y, you will have 2x. For a given height y, you will have 2x. This is your y, same y, but you have 2x. About the point of symmetry, there are 2 positions in x-axis where the y is same. The y is same. And hence the quadratic. A quadratic has 2 solutions. If I tell you what is theta, if I tell you the value of y, you solve it, you will get 2 x coordinates, which will tell you one coordinate is located on the left of the axis of symmetry. The other one is located on the right side of the symmetry line, and both at both x-axis, which is this, the vertical displacement is identical. For a given y vertical displacement, 2 values of x, one on the right, one on the left, about the symmetry line passing through the highest point of the projectile. Quadratic. For one y, 2x. All right. So now let's talk about more. Let's look at this equation. in y-axis. Okay, this tells you the position of the projectile in y-axis at time t. If I know the value of y, I know the value of my initial velocity of launch, I know my angle of projection. If I substitute them, I will get a quadratic equation in t. If I solve a quadratic equation in t, I will get two values of time for a given y. So for a given y-axis displacement, two times t1 and t2. Why? Because you are achieving a displacement of y here and y here two times, right? So first time when you achieve the height, this on the left hand side is a root of this equation. The second root of the equation is here. So you're moving across the symmetry line, reaching here, time has elapsed. It takes less time to reach this point and more time to reach this point. But these two times, obviously this is not a graph of y and time, but in y-axis, motion, if time is there, then for a given y, you will have two roots t1 and t2 where the body will be able to achieve the same vertical displacement. If you solve this, again a quadratic. But the point of symmetry is this: one time will be located on this side and the other time is located on this side. Let me give you an example to make it easy for you. So say let's say time taken by the body to attain the highest is 9 seconds. Right? So you know half the time of flight is 9 seconds. If the body is at this height at 7 seconds, okay, at this point, 2 seconds before attaining the highest point, then so there is a 2 seconds gap. Now at 11 seconds, it will be here. You don't need to calculate it. By symmetry, it took you 2 seconds from this height to reach this highest point, and again to reach the same height, which is this. These two heights are same. To reach from here to the same height, you will take another 2 seconds. So on the left hand side, you took 2 seconds to reach, and on the right hand side, to attain the same height, you will take another 2 seconds. Symmetry. Quadratic. All right, let's move forward. Let's look at this equation. Now you will say, this is the range, right? Yes, it is range. No doubt about it. This also is quadratic. Now a lot of people get, startled. How is this a quadratic? What do you mean by that? Let me explain you. If you see this equation, and this is more mathematically being discussed than physically, right? But we will explain it physically also. That is what happens in real world. But if you look at this equation, right? If I put theta is equal to 90 minus theta, which means I put another angle which is alpha is equal to, the range is u square sine of 2, 90 minus theta upon g is equal to u square sine of 180 minus 2 theta by g is equal to u square sine 2 theta by g, which means you're back. Your range is this. If you use an angle of projection, which is 90 minus theta now, you change the angle. So you use 30 degree first to launch the projectile. And now what you do is, instead of 30 degree, you use 90 minus 30. So earlier your angle was 30 degrees. Now your angle is 60 degree. 90 minus 30. Your range does not change. So there are two thetas which give you the same range, quadratic, two solutions. That's where I'm coming from. This concept is known as complementary angle. For a given value of the theta, there exists another angle which gives you the same range. Quadratic. Two solutions. Project at 20 degrees. If you project at 70 degrees, 90 minus 20, the range remains unchanged. Two solutions. A lot of emphasis in these questions on symmetry, two solutions. Symmetric about this point, highest point. So we're talking about angle. One more important thing about this, if theta is equal to 45 degree, the range comes out to be u squared by g. This is the highest range you can expect. If you're given a particular velocity u and you're asked that project it at an angle so that you get the maximum range, you want to go the farthest in x-axis, always project at an angle of 45 degree. If you project at 45 degree for a given launch velocity, you will always reach the farthest point. The earlier discussion was complementary angle. This discussion also was about angle. You do something with the angle, results are different. So that is the power of angle in a projectile motion. But that's a point I'm going to discuss now. What is the power of this angle? You have seen, if you make the angle theta is equal to 45 degree, a very powerful outcome of maximum range is coming in. What exactly is the power of this theta? Let's discuss. The power of this theta is, if you increase theta, the time of flight, which is given by, I think we calculated it somewhere, right? Yes. So the time of flight is proportional to sine theta. More is your angle, longer you can be in the air. So if you want to fly, if you want your projectile to be in motion for a longer period of time of flight, project at a higher angle. Because the dependence is sine theta. Sine theta increases if theta increases. We're talking about 0 to 90 degree here, okay? Keep it simple. 45 degree, then 60 degree. 60 degree angle is going to be showing you more time of flight. Powerful, right? The angle is very powerful. Get a hang of it. Go to my projectile playlist. You will see some fantastic questions from books like Resnick Halliday, H.C. Verma, and other books where I've solved these questions. Graphical questions, algebraic questions, calculus-based questions. I'm not sure about calculus, but algebraic and graphical a lot. Let's not talk about the power of angle. Look at the height, maximum height. If you increase your theta, okay, so theta is equal to u square sine square 60 upon 2g is equal to u square 3 by 2 upon 2g is equal to u square 3 upon 4g. Okay, so that's your theta. Sorry, that's your height, right? Sorry. If you put the value of 45 degrees, u square sine square 45 upon 2g. So this is going to be u square by 4g. Higher is the angle, more is the height. If you want to go farther up, increase the angle. Keep increasing the angle. Make the angle 90 degree. That's your highest motion only in y-axis. 90-degree projection means what? This angle becomes this angle. Angle is very powerful. Impacts range, impacts time of flight. I hope this lecture is making sense and is helping you understand the fine points of a projectile motion. If you still have any doubts on the projectile motion, feel free to write your comments and questions. But do watch my playlist on projectile motion. You will see some startling questions solved there like this. Saves you time, increases your conceptual clarity. I'm winding this up now. Thank you very much for your time today. See you soon. Bye. Thank you very much.